The stuff from 7.1 that I'm going to ask for going to be stuff like this. So prove identities using the Pythagorean even, odd, and reciprocal, reciprocal and quotient. Number one, prove the following. Cosecant squared times 1 plus sine squared equal to cotangent squared. All right, obviously we should pick the left-hand side, right? Let's see what happens. So I'm going to pick this guy. Okay. The first thing I would do is, let's see. I don't see a Pythagorean that's obvious. Like 1 plus sine squared is not anything. So try multiplying it out, see what happens. What I'm thinking is, once I distribute the cosecant, sine and cosecant are inverses, right? The reciprocals. So I can cancel that thing. So change this one. Using the reciprocal identity. So these cancel, leaving you with cosecant squared x plus 1. You know what? I made a little error here. I'm going to change this to minus. Otherwise, it's not true. And I told you I was not going to give you stuff that is false. Okay. Sorry about that. So at this point, we should see this is a cotangent, right? So Pythagorean from here to here. Identity. Cosecant squared x minus 1 is equal to cotangent. Any questions on any of the steps? Yeah. There is a lot of options. You can take many different paths and you can still get there. Experience will teach you what's the shortest path, but other than that, you just gotta try things. So knowing your identities, being good at algebra, comfortable with fractions will allow you to just try and play around and eventually you'll get there. But there's certain things that show up multiple times, like these ratios, you'll see stuff like this, you know. You see it, you'll see it in a sign or the opposite, that should be catch. Let's see one minus sign, maybe I can change that to total time, get that up. But I want to keep the goal on my head, always take here. That should be your guide. Any other questions on number one? Yeah, I'll put number two in the next page. So from 7.1, I'll just ask stuff like this. There's many different types of proofs. I'll try to pick something, you know, decent, nothing insane. Yes, cool on this page. All right, let's move on to 7.2. 7.2 is the sum and difference identities. So number two, given that sine alpha is equal to 2/3 and cosine beta is equal to -1/4, with alpha being between pi/2 and pi, and beta being between same spot. I don't think they are equal to, actually. Yeah. Part A, find sine of alpha plus beta. Part B, find cosine alpha minus beta. So I'm gonna ask something like this. I don't know if I'll have two parts or not, but for sure, I'm gonna give you some information. Find the sum of angles. Okay. What I recommend is you start by building a triangle. Build one for alpha. So here's our work. So sine of alpha is in this quadrant. Which quadrant is this? Yeah, it's gonna be 2. So they're both in quadrant 2. So sine should be positive, so that's correct, right? So opposite over hypotenuse. Cosine should be negative, so that's good. Hypotenuse is never negative, so adjacent piece will be negative. Okay. Then I just find the missing piece, do your Pythagorean theorem, and you should get that this is -√5. This is square root 15. Once you have your triangle completed, you can start answering the question. Do you have any questions on the Pythagorean part? Is that okay is this okay? All right, now I'm gonna go straight to part A then. So let me know. Sine alpha plus beta is equal to, formula says sine alpha cosine beta plus cosine alpha sine beta. So plug in your sine alpha, that was given to us, right? 2/3. Even write this bigger. Cosine beta was given to us, right? Plus cosine alpha. What is cosine alpha? Negative square root 5/3. Sine beta. Should be opposite, right? Over 4, correct? You want to save your triangles built, you just write them down. Okay. It's not too bad, I hope. At this point, you're pretty much done. Just do some algebra. Does the idea make sense? It's all right. Yes. Well, in algebra, we have a property that says square root a times square root b is equal to square root a times b, right? So that means we can multiply the 5 and 15. So what is 5 times 15? This would be simply -2/12, right? This will be negative as well. Over 12, 3 times 4, 5 times 15. That's 75? Yeah. So that's all we can do. Doesn't, well, actually it does reduce. Right, 75 reduces. Right. You separate the squared factor. Square root of 25 is 5. There's this one was minus. And this one was -2. Okay. Any questions on part A? The part B will be very similar. Cosine alpha minus beta. I wrote the formula down earlier. Let me see. That's equal to cosine alpha times cosine beta plus sine alpha sine beta. So that will be cosine alpha is -√5/. 3 cosine beta times -1/4 plus sine alpha 2/3 times sine beta √15/4. So we should get 12 on the bottom. Let's go to the amount of space. I'm going to skip the simplification. Negative times negative is positive. 2 times that is just 2. You guys agree with part B? That clear? Or is it weird? No, it's early, but let me know. Negative √5. Positive √5. 2 times 15 is just 2 times. The bottom is 3, 4 is 12. 3 is 12, so they have the same denominator. So you just add these results. Any other questions on part B? So you for sure have one of these types from 7.2. You also have, you might have a proof type. We'll do that next. Thinking like 40% of the test will be solving something or having a value. 60% will be just prove the statement. Okay. You guys okay on this page? Cosine x plus y times cosine x minus y is equal to cosine squared x minus sine squared y. So it looks like we should start on the left-hand side and do our sum and differences. Things should cancel and turn into the right side. So use your sum of angles for cosine. So I'm going to put it in brackets for that cosine part. This would be cosine x cosine y minus sine x sine y. So that's the first expansion, the cosine x plus y. And it's all times, so the next one, whatever this garbage will be, it's going to be on the formula. Cosine x cosine y minus, no, plus sine x sine y. So this is the sum difference formulas. All right, so at this point, you see a conjugate, right? You could just FOIL everything out, multiply everything. I'm hoping that you see this as A minus B minus A plus B. Different squares from, I think I first saw it in sixth grade. I don't know if it's still taught in sixth grade. Or seventh. But you know what I'm talking about, right? You multiply something like this, you end up with these two terms, correct? You know, you factored, you multiplied this over and over again. Many math classes, I'm sure. So this is my A minus B, A plus B. So you could multiply or skip to the answer. So the formula says this will simply be the first term squared minus the second term squared. If you FOIL it all out, everything will cancel, leaving you with those two regardless. So if you don't see it, then you would do extra work and get there anyway, which is fine. I don't care how you do it. As long as your math is legit, it doesn't matter. I'm just showing you a shortcut. So at this point, we pretty much have what we think we do anyway. We're getting close, right? Not quite there. But we should know that if you square two products, they both receive the square, right? Okay. So what I'm thinking is the answer only has a cosine X and a sine Y. So let's mess with these two. The cosine Y and the sine X. To change those into something else. Let's see. I'm not going to mess with the stuff that I want. I want it to be cosine X, so I'm not messing with that. I'm changing the cosine Y to be 1 minus sine Y. And I'm changing this one to be 1 minus cosine X. You see what I did? But from here to here, we applied Pythagorean twice. So I change cosine squared into this, sine squared X. At this point, distribute, then hope something cancels. I'm hoping we just end up with these two. So distribute your cosine, you end up with this minus this guy. Distribute this. I'm going to put a bracket because there's a minus and a product, so I don't want to confuse myself. I'm going to do this multiplication backwards. Is that weird? Is that okay? This times that, this times this. So that'll leave us with sine squared y minus sine squared y cosine squared y. Distribute your negative, and I think these will cancel, like we hoped. You see how these are Oops, I made a mistake. This should be X. This should be X. You see how those are the same thing, right? These will cancel. Leaving me with what I want, with what I wanted. So if you see like sum of angles, that's probably where you want to start. Okay. Like a bunch of products like sine, sine, cosine, cosine. Try product to sum, something like that. Any question number 3? Any part, beginning, middle, or end? Is it clear? Is it weird? Okay. Well, let's move on to 7.3 then. So that's pretty much all I'm gonna ask from 7.2 is maybe some proof stuff and that triangle thing, with the sum and differences. I don't think we did double angle till later. Yeah, 7.3 was double, so you won't see that there. All right. You guys cool on this page then? All right. 7.3. This was the double angle section. And half angle. Again, you can have the unit circle for your exam separate if you want. Any page that I sent you, the formula page. If you want to make your own front and back with any formula you like or definition. Okay, just no examples, just formulas. I'm not going to force you to memorize this. There's a lot of them. Okay. I had to memorize them and I was not happy about it. Okay. So for 7.3 double angle, it'll be similar to what we did with the sum of angles. It's just that you have to be careful with the double and a half. Find out what quadrant you end up in to choose the right sign, choose the right formula. Okay. So given that sine x is equal to negative 12/13, and our x is between pi to 3 pi over 2. So what quadrant is this? Yeah, it's going to be 3, right? So that's something you need to be able to spot on your own. So part A, find sine of x over 2. Part B, find cosine of x over 2. C, sine 2x. And D, cosine 2x. All right. So before we do anything, we should probably find the yeah, let's do some side work here. We know that x is between pi and 3 pi over 2, right? So that would mean that this would imply yeah, I guess down here. If I divide everything by 2, I would then be in quadrant. What quadrant would that be? We said this was quadrant 3 to begin with. The pi over 2 to 3 pi fourths. Yeah, so this would be quadrant 2. In quadrant 2, cosine is negative, right? So we have to keep that in mind when we do the half angle stuff. If we double everything, one moment. Be weird. Times 2. Yeah, that's fine. It doesn't matter for the double. I'm sorry. I was overthinking it. All right, so let's get started. Part A. What do we need for sine x over 2? I think we're gonna need a triangle, right? What did they give us? Yeah, sine equal to negative 12 over 13. So build a triangle using this this right here. This is one of the magic triangles. So when you try to find the missing side, it's gonna end up being plus or minus 5. You're gonna choose negative 5 because where x is in quadrant 3. Okay. Is that clear or no? Okay. So if you do your Pythagorean theorem, let's pretend we didn't know what that was. You would plug in your B and your C. So a squared is equal to 13 squared minus negative 12 squared. So a squared will be, what is that? 169 minus 144, is that right? So square root both sides. You're gonna end up here. If you didn't see it was a special triangle, you would have to solve for it. And you would end up with plus or minus. You need to choose minus because of quadrant 3. Okay. Is that clear? Okay, so part A, x over sine of a half angle, x over 2, is equal to this in your formulas, right? I gave you this on your formula sheets or in the notes. Do we choose plus or minus? And what determines that? Yeah. Yeah, it'll be determined by the half angle, location of half angle. So quadrant 2 is sign positive or negative. Yeah, so we're gonna choose plus. Does that make sense? That's the only reason I set this up. And so we can keep ourselves organized. So at that point, we pick the plus and then plug in your cosine. So this will be 1 minus cosine of x. So cosine is adjacent over hypotenuse. Divided by 2. At this point, do some fraction work, and you'll end up with 1826. This will be my side work here. I'm trying to write smaller for this part. Anyway, this is just whatever. All this is just me playing with fractions, but does this main idea make sense to you? Here to here. That's the pre-cal step. Yeah.
How do you know if, what side is
But it depends on the angle, so it's sine of x, right? Where the question becomes, okay, where is x? So x is given to us between pi and magnitude. So in quadrant 3, cosine x is negative. Sine is also negative. So this was determined by the location of that x. Okay.
I have a question. How do where do 13? Like in the end.
Oh, everything else was cool?
Hmm?
This is,
Yeah, like I get that, but I don't.
oh, you were asking once for 13, for 13.
Oh. I think you gotta do the same with the 2, right? How you did with the 13. You can ask for the 3.
Yes, that's screw at the top. Yeah, not 30.
Mhm.
I think you shouldn't have screws at the bottom, so you maximize it. You can get to here. Although I would accept this one or that one. It's fine. You don't have to go that far. The main thing, 60% of the competitors right here. Plug in the stuff, control the right signs. You had cosine. The rest is simplification. Yeah.
How do you know which side goes which?
Look at the quadrants, right? Look at your quadrants. We know that everything here is positive, right? You go to quadrant 2. We know that x is negative here because you cross the zero. Y is still positive, down here they're both negative. Over here, x is positive and sine is negative. So if you forget, you can make this little note and say, you know what, these are plus, these are minus plus. minus, minus. Plus minus. So just because of locations, that's why they're plus or minus. So when we talk about sine or cosine, it depends right here, by there, not the rest. And they told us where we were. X. Which then determine where x over 2 was. So we just gotta figure out what are the signs for x and y. Sine and cosine. Does that make sense? Circle. Another way to think about it. If you look at your unit circle, do you have it on here? I think I might have it somewhere. Where is it? Okay, let me just pull it up for you. So just like this, right? If I go below 0 on the x, obviously x is negative. If I go below 0 on the y,
Yeah, my question
Negative.
was, which one do you have to pick? Like the y lines.
so sine over 1. Cosine over sin. So if you look at this, well, the x is 1 and almost plus. The sine cosine here. X is no negative. Cosine negative in this section. Sine positive. Here. Over here, they're both negative. See, right? Sine, cosine, sine are negative. That's probably it. That makes sense. Okay. Any other questions? This is the time to ask because test is coming soon. Yes. Yeah, I've been at the lab upstairs every Monday, Wednesday till about. What's up? I get there about 10:15, 10:30 till 12. Sometimes earlier. Yeah, you guys cool on part A? Okay. So cosine x over 2. All right. It'd be funny. Which one should I choose? Plus or minus?
Would it be minus?
Yeah. Do you see why?
Yeah, it goes together.
Yeah, so whenever you're doing it, you look at location of x over 2. Okay, if we're talking about regular cosine, we look at the location of x. That's it. Okay, so just plug it in and we're good. Cosine we said was adjacent over hypotenuse. Over 2. And that's pretty much the answer. Just make this pretty. that will become oops, just wrote the same thing again. Eight over 26. Which you can reduce if you like. Square root 4 over 13, which is square root, which would be 2, or square root 13. That looks messy. This would be the most simplified answer here. If you stopped anywhere along the way, I would have been fine. Choose the right sign. You find your sine and cosine. I'm gonna be, I'll be happy. Okay. Part C, sine of 2x. Here the signs don't really matter, except for sine and cosine, right? As long as you got those right, you'll be good. That will be 2 times sine, negative 12 over 13 times cosine, which is adjacent over hypotenuse, which will be multiply all that garbage. Negative times negative is positive, so this whole thing will be positive. 13 times 13 will be 169. 12 times 5 is 60, right? Times 2. Do you agree with the solution? Bring out space here. Right, so double angle formula from the notes. Do sine cosine. We found sine and cosine with the triangle. Plug it. Okay. I'll do D on the other side. There's not enough space here. You guys, cool if I turn the page. Part D. Cosine 2x. There are 3 different formulas to choose from. I'm going to choose this one for no reason. So just plug in cosine and sine. Cosine was negative 5/13, right? Sine was negative 12/13. So that would be 25 over 169 minus 144 over 169, which becomes negative. What is that? 119? Oh, I'm sorry. Yeah. Is that what you got? Okay. The double angles aren't too bad. I think the half angles are the harder ones. Anyway, any questions on A, B, C, D? Problem 4. Yes.
Does it matter by the first one?
You mean because there's 3 of them, right? Yeah, you can choose either any of them, and you'll end up with this. It'll just be slightly different along the way, but it will be negative 119 over 169. Okay, number 5. Prove the following. Sine 3x is equal to 3 sine x cosine squared x minus sine cubed x.
The last part, that's a 3 ray.
Yeah, it's a cube, sine cube. So I'm thinking of choosing the left-hand side only because we are in a double angle section. Only reason. I feel like this would also work, but I know this will work for sure. Do you agree that sine 3x is the same as 2x plus x? So apply your sum of angles to this. That way I can take advantage of the 2x because we have a lot of double angle formulas. Make this your alpha and beta. So that would become sine alpha, which is 2x, cosine beta, plus cosine 2x sine x. Okay. So I apply these sum here. Sum and difference property or identity. So now you see 2 double angles, right? Sine 2x, cosine 2x. So apply it to both and see if we can get some cubes and squares to appear. So right here on the sine 2x, this would be 2 sine cosine times cosine plus cosine times or cosine 2x will be cosine squared minus sine squared. Right? So we expanded the double angle right here and the sine 2x here. The 2 sine? It's part of the formula. Sine 2x is equal to 2 sine cosine. It's built in. So if you look up the sine double angle, it'll have a 2. Okay, so multiply this out, you're gonna get 2 sine cosine squared. Multiply that out, you're gonna get cosine squared x sine x minus sine cubed x. It looks like we're almost there. Are you still with me up to this point? Okay, these are the same, right? So 2 plus 1. That's it. So here to here. Here we did the double. Formulas from here to here. After that, we just multiplied stuff. Any questions on number 5, 7.3? All right, we'll do the second part Wednesday, Friday, I guess. You take roll. Sadie, Jadlyn, Ava, Andre, Zoe, Aaron, Michael, Alexandra, Juan, Juliana, Epifania, Andrea, Kimberly, Diego, Teresa, Hunter, Angelica, Connor. All right, guys, we'll stop a little early today. Please catch up on your homework. We'll start on 7.4 next time. Okay. If you have any questions, let me know. If not, I'll see you Wednesday.